Hi guys, welcome to Lesson 2.5, Literal Equations and Formulas. Our objective for today is that I can rewrite literal equations and that I can use formulas. Our essential understanding, the one that you have on your page, is from Lesson 2-4. So the understanding for this one is that when you work with literal equations, you can use the methods you have learned in this chapter to isolate any variable. So let's start with our definitions. The first one is literal equations. A literal equation is an equation that involves two or more variables. And a formula is an equation that states a relationship among quantities. All right, so problem number one is going to be rewriting a literal equation. And we are told in our directions we want to solve each of these equations for y. So we can go ahead and do that with our properties of equality. We're going to just start by adding 9 to both sides of our equation. So we have 3x plus 9 is equal to 3y. Now we want to get y by itself, so we're going to divide both sides of our equation by 3. And the resulting answer is going to be x, because 3x divided by 3 is just going to be x, plus 9 divided by 3 is 3. And that is equal to y. Problem number 2, 2x plus 4y is equal to 12. We're going to start by subtracting 2x from both sides of the equation. We're left with 4y is equal to negative 12x, negative 2x plus 12. Divide both sides of our equation by 4. And we've got that y is equal to negative 2 divided by 4 is negative 1/2 x. Or you could say negative x over 2, both acceptable, plus 12 divided by 4 is 3. Letter C, again, we're trying to solve for y. So we're going to start by adding 5x to both sides of our equation. And we've got 5x plus 4 is equal to 2y. Divide both sides of the equation by 2, and we're left with 5/2 x plus 2 equals y. Now, for these problems, we would prefer that you guys just leave it as the fraction, but if you were to write it as 2.5 plus x, or 2.5x plus 2, that would be acceptable. All right. Why don't you guys try these bottom two and then come back for the answers. So letter A, we are told that we want to solve for x. You guys need to make sure you are paying very close attention to the variable we are asking you to solve in every problem. So we're solving for x, so we need to start by subtracting 15 from both sides of our equation. So we have y minus 15 is equal to x over 3. Multiply both sides of our equation by 3. And when we use distributive property, we get 3y minus 45 is equal to x. Letter B, we want to solve for y, which is what our directions are telling us. So we're going to start by adding 5x to both sides of our equation. We get 10y is equal to 5x minus 25. Divide both sides of our equation by 10. And we get y is equal to 5 divided by 10 is x over 2. Or you could say 1/2 times x minus 25 over 10. You could reduce that to a decimal and write minus 2.5 if you choose to, but I'm just going to leave it as a fraction. Moving on to problem number 2. This is where we have found that 8th graders tend to struggle, and it is when we are going to be rewriting a literal equation with only variables. Now, we don't have any numbers, we only have variables, but we can apply the exact same rules that we would if there were numbers there and be able to solve for a variable. So we're being told that we want to solve a and b. We want to solve them both for x. So that's what we're going to do. So the first thing we need to do, x is right here. So we need to move this minus r, or the positive r, by subtracting r from both sides. So we're going to be left with negative t minus r is equal to px. We're still trying to isolate x, so we're going to divide both sides by p. And we get negative t minus r over p is equal to x. And that is our final answer. We are applying the exact same rules, we just don't have any numbers involved. So letter B, we have a over x minus b over x is equal to c. Well, first step, I want to combine like terms. So I see a fraction that has the same denominators, so I can just subtract the numerators. So we have a minus b over x is equal to c. Now we're still trying to solve for x. So I'm going to multiply both sides of my equation by x in order to get it out from the denominator. So now I have a minus b is equal to cx. Last step, we want x by itself, so we're going to divide both sides of the equation by c, and so we get a minus b over c is equal to x. Okay, why don't you guys give the bottom two a shot there, come back and check your answers. So letter A, we're told we want to solve for x, and this is an equation that is in standard form, which is something you guys are going to be learning about in a couple chapters. So we want to solve for x. We start by subtracting by from both sides of the equation. So we have ax is equal to c minus by. Divide both sides by a, and x is equal to c minus by over a. And there is nothing that we can do to simplify that, so I would just leave it as a fraction just like this. There's no need to do anything else. All right, letter B is a form that you've probably seen before in 7th grade, and it is our slope-intercept form for an equation, y equals mx plus b. Again, we'll be seeing this more in a couple chapters. But we want to solve this one for m, which is our slope. So the first step is going to be subtracting b from both sides. And we get y minus b is equal to mx. Our second step is going to be divide both sides by x because we want to find m by itself. So y minus b over x is equal to m. Okay? Now, bottom half of the page here, we have some common formulas that you're going to use in this class and in others. So some of these you should already know. The ones that are off on the left-hand side here are formulas involving physical dimensions. So what I would say is those I would expect are formulas that you already know coming into this class. So the perimeter of a rectangle is equal to 2 times the length plus 2 times the width. The area of a rectangle is length times width. The circumference of a circle is 2 pi r. The area of a circle is pi r squared. The area of a triangle is 1/2 base times height. Now, some of the more chemistry and physics formulas that you're going to be using. Distance traveled, which we use in the monorail problem. Distance is equal to r times t, rate times time. Density, you're going to be using in science. Density is equal to the mass divided by the volume. Temperature, the degrees Celsius is equal to 5/9 times the degrees Fahrenheit minus 32. Potential energy, you're going to be doing this in second semester in science, especially with the roller coaster project and the marble project and the car crashing project. So you're going to have potential energy is equal to mass times gravity times height, where gravity is a constant, depending on what planet you're on. Kinetic energy is 1/2 mass times velocity squared. All right, so those are common formulas that you're going to be seeing, and we will be giving you, especially if we're using any of these formulas, we will give those to you. All right. So problem number 3 is asking us to rewrite a geometric formula. And so the first one it asks us to solve the temperature equation for F. We want to know what the degrees Fahrenheit are. So we can start off, our equation is C equals 5/9 times the degrees Fahrenheit minus 32. So our first step that we want to do is to get rid of this 5/9 that's out in front. So we're going to multiply by 9/5 to cancel out the fraction. So we're going to be left with 9/5 C is equal to F minus 32 because our fractions canceled out. So now we just simply need to add 32 to both sides of our equation. And we find that 9/5 C plus 32 is equal to the degrees Fahrenheit. So problem A has been solved. Now we need to use that for problem B, which is saying it is currently 33 degrees Celsius. What is the temperature in Fahrenheit? So now we can just plug our degrees Celsius in and we'll have our degrees Fahrenheit. So we have 9/5 times the degrees Celsius, which is 33, plus 32 is equal to the degrees Fahrenheit. All right, and when you plug that into your calculator, you find that 33 degrees Celsius is equal to 91.4 degrees Fahrenheit. Don't forget to use your units. So that was the high today, or at least it was the temperature when I wrote this. All right. I want you guys to try letters A and B down below, and we will go over the answer. So we're told we want to solve for the perimeter of a rectangle for length. So perimeter of a rectangle is equal to 2 times the length plus 2 times the width. We start by subtracting 2w from both sides. So perimeter minus 2w equals 2 times the length. Divide both sides by 2, and we find that 1/2 times the perimeter minus w is equal to the length. And I use a script L for length. Otherwise it looks like a 1. All right. Letter B, what is the height of a triangle that has an area of 24 square inches and it has a base with a length of 8 inches? So we start off by writing our equation. The area of a triangle is equal to 1/2 times base times height. And we plug in our information. We know that the area is 24 square inches. We know the base is 8 inches. So we simplify. 24 is equal to 4h. Divide both sides by 4. And 6 inches is equal to our height. All right, again, make sure you have your units. Problem number 4, word problem. Pacific gray whales migrate annually from the waters near Alaska to the waters near Baja California, Mexico, and back. The whales travel a distance of about 5,000 miles each way at an average rate of 91 miles per day. About how many days does it take for the whales to migrate one way? So let's just underline our important information. We have 5,000 miles each way. We have our average rate is 91 miles per day, and we want to know how many days to go one way. So remember, whenever you guys read a word problem, underline it, highlight it, make marks on it to help identify those important pieces of information. So we're going to use our distance formula. Distance is equal to the rate times the time. We know the distance. It's going to be 5,000 miles. We know the rate, which is 91 miles per day, and it's multiplied by time, which is what we're trying to find. We're going to divide both sides by 91, and 5,000 divided by 91 is going to be 54.95. So our time is approximately 55 days. Okay. Our second problem, the formula S is equal to 1/2 AT squared represents the distance S that a free-falling object will fall near a planet or moon in a given time, t. A is the representation of the acceleration due to gravity. A free-falling object near the moon drops 20.5 meters in 5 seconds. We want to know what is the value for A for the moon. What is the acceleration due to gravity on the moon? All right, so we're going to start with our equation. We know our distance is S, so we start off, I'll just rewrite the formula. S equals 1/2 AT squared. S is 20.5. That's equal to 1/2 times the acceleration, which we're trying to find, times time squared, 5 squared. So 20.5 is equal to 1/2 times A times 25. 20.5 is equal to 12.5 A. Divide both sides by 12.5. And we find that the answer is 1.64 is equal to A. Now this is a unit that I'm not going to expect you to know. And the unit for the acceleration due to gravity is 1.64 meters per second squared. Okay, that is our final answer. So make sure you guys fill in your level of understanding. 1, I'm completely lost. 4, I can teach this lesson. Please make sure you write down any questions that you might have. That way we can address them first thing in the morning in class. And don't forget to write the summary. Describe what you have learned in a few sentences. All right. Have a great night, and we will see you all tomorrow.